You know, you see them every single day. These fluffy, seemingly weightless cotton balls just drifting across the sky. But what if I told you that's all an illusion? A beautiful but incredibly heavy illusion. So that's the big question we're going to tackle. And I'm telling you, the answer is going to completely change the way you look up at the sky. I mean, our perception is that they're just light, airy, almost nothing, right? But the reality? Clouds are vast, heavy structures, absolutely packed to the brim with water. And that is the absolute key right there. See, clouds aren't just water vapor, that's invisible gas. No, they're made of trillions of actual physical liquid water droplets or tiny ice crystals. And anything that's made of physical stuff has mass, which of course means it has weight. So that brings us right back to our big question. And it's a question that one atmospheric scientist, Margaret Limon at the National Center for Atmospheric Research, decided she was going to figure out once and for all. But this is where it gets tricky. I mean, how in the world do you weigh something you can't even touch? You can't just put a cloud on a scale, right? So Limon had to get pretty creative. And what she came up with was this brilliantly simple three-step process. First, she needed to figure out the cloud's volume. Second, use data that was already out there to find its water density. And third, well, just do the math. Volume times density is going to give you the mass. Okay, so how do you measure the volume? Well, Limon measured the shadow of a typical cumulus cloud, the puffy white ones, while the sun was directly overhead. She found it was about 1 kilometer across. So assuming the cloud was roughly a cube, 1 kilometer long, 1 kilometer wide, and 1 kilometer tall, that gives you a staggering volume of 1 billion cubic meters. All right, now for part 2, density. Thanks to other studies, scientists had already measured the water density inside that kind of cloud. And it's tiny, only about 0.5 gram of water for every cubic meter. To put that in perspective, that's like taking a small marble's worth of water and spreading it out in a space big enough for 2 people to sit in. So, what do you think happens when you take that absolutely massive volume and multiply it by that teeny tiny density? You get a number that is truly mind-boggling. That's right. The water in just an average, everyday, fluffy white cloud weighs 550 tons. That is 1.1 million pounds, just floating peacefully over your head. I mean, to really wrap your head around that, that's the same weight as about 100 elephants, or a fully loaded Airbus A380 passenger jet. Just try to picture that floating a mile above you. This immediately brings up a huge paradox, doesn't it? If there are hundreds of tons of water hanging out up there in the sky, why doesn't it all just come crashing down on top of us? Well, the answer isn't magic, it's all physics. It comes down to this really delicate balance of 3 key forces that all work together to basically defy gravity. First up is what you could call the power of the small. That massive 550-ton weight isn't in one giant solid block. It's spread out across trillions and trillions of microscopic water droplets. Each one is so unbelievably tiny that the force of air resistance alone is pretty much enough to counteract gravity's pull, keeping them suspended. Second, you've got buoyancy. Now, a cloud isn't just water, it's water droplets mixed with humid air. And that whole mixture, as a single unit, is actually less dense than the cooler, drier air that's all around it. It's the same reason a giant steel ship can float on water. The cloud just floats on the denser air around it. And third, there is an invisible elevator. As the sun heats the ground, that warm air starts to rise. This constant updraft, it's a process called thermal convection, acts like a continuous push from below, lifting up all those droplets and holding them in the sky against the pull of gravity. So what you've got is this constant battle, a cosmic tug of war. In one corner, you have gravity, relentlessly pulling those 550 tons of water down. But in the other corner, you have this powerhouse team of 3, air resistance, buoyancy, and those thermal updrafts, all pushing back, keeping the cloud afloat. And for a while, it's a perfect stalemate. But what happens when that delicate balance finally breaks? What happens when that downward force finally overpowers all those upward forces? Well, the answer is rain. It's really that simple. The conditions inside the cloud change, and those tiny little droplets start bumping into each other and merging, forming bigger, heavier drops. And eventually, they get so heavy that air resistance and the updrafts just can't hold them anymore. Gravity finally wins, and the drops fall to the ground. So the next time you look up at the sky, just remember, it is not an empty canvas. It's a vast ocean of air, carrying these incredible islands of unimaginable weight. It's a constant, invisible battle of physics happening right above our heads, all day, every single day.